This is joint work with my student who couldn't be here, and also with Byron, Wallace from Northeastern, who is his co-advisor, and a cadre of other great students. Quick service announcement. So I'm at a School of Information, which not everyone has heard of. Jake Wobrock, I guess, who's here, has put it really well. This is a place where really interesting interdisciplinary computing stuff happens. So do think of us when you're trying to figure out where to send your students for graduate studies and jobs later. So one thing that information schools have taught traditionally is information literacy. So when people, for instance, are searching for information online, how do they not only find information, but how do they assess it and reason about sort of sources? So about 10 years ago, actually, former President Barack Obama declared a National Information Literacy Awareness Month, saying, though we may know how to find the information we need, we must also know how to evaluate it. Or if we like to consider a somewhat more amusing source, Stephen Colbert has coined this term truthiness, right? It used to be that everyone was entitled to their own opinion, but not their own facts. But that's not the case anymore. So we live in a very interesting time when sense-making has become increasingly difficult, and our traditional skills for doing information literacy ourselves is getting more challenging. So we've seen a rise of sites like PolitiFact and Snopes, where journalists are trying to at least do some fact-checking of some of the most significant claims that are out there. And even tools like Google, being used for search, are now thinking about trying to embed little bits of search results like this to help people who are searching for information do a little better sense-making about what to believe. So journalists, of course, are limited into how many facts they can check. So there's been a rise of also sites of doing crowdsourced fact-checking. And a lot of work in automation. I'll say more about this. So you might imagine like a claim, Facebook shut down an AI because chatbots developed their own language. There's some headline from an article that was written about this. And what people try to predict is first the stance of the story. Is it supporting, refuting, or just mentioning the claim? And they might try to then predict whether the claim is true or not. So there's been prior work, like I said, on trying to, in the natural language processing space, try to predict the stance of articles, trying to predict whether claims are true or not. And there's sort of been an explosion of work in this space. So there was a fake news challenge recently. About a month ago, there was another fact-checking open shared task. In a month, there'll be yet another at EMNLP. But while this work is great, I think it's pretty limited in that it's not thinking very much about the human aspect. So we're seeing a rise of great interest now in fair, accountable, and transparent AI. We have new conferences in AAAI and ACM. But, we know that many people today don't trust fact-checking sites, and they don't trust sites like CNN. So why would they trust your black box machine learning classifier when it tells them what to believe? How do we reason about sources of potential bias, which we know are coming in more in the data sets machine learning tools are using, or in the algorithms, particularly maybe hidden in ways like, say, if we have a deep learning model? Do people really only want to know what's true or false? I think what we see a lot is what people are trying to explore a space and learn about it and understand about the competing views and the perspectives in it. So how can we enable people to really combine their knowledge and experience with what automated tools might be able to tell us in terms of scalability and finding related stuff and telling us something about the credibility of it? So we'd like to have a way to sort of facilitate joint AI human reasoning, a way for the people to correct the errors the system might make or vice versa, or even to personalize the systems for the users. And in general, work on designing human-AI partnerships is not new. Eric Horvitz has this great work on mixed initiative we borrow from. But I think there's a really interesting sort of space happening right now in the larger Chi community, where as we start to see AI become more ubiquitous, people are trying to think about AI as a design material. And how do we enable folks who have the real strength for working with computer-human interaction to also think about integrating these potentially very technical machine learning models into user-facing systems? So just quickly mention a little past work we've done. This is still a live demo you can play with. We were looking at sort of the rise of memes on the web, and so you're reading a story on CNN, and maybe you don't know quite the provenance of where the information you're getting is from. So we can find that, oh, here's some phrase and showing up that story. It actually was in a blog yesterday, and before then it was on Twitter. So a way of sort of trying to understand about the reliability of source of information through provenance. Much more recently, we had some work sort of in this NLP fact-checking space. We had a hybrid model, though, so we had the Mechanical Turk crowd doing some labeling along with the automated prediction to improve accuracy. And we sort of had a joint graphical model. And the reason why to think about doing graphical models instead of your favorite new deep learning model today is because they're much more transparent and explainable. Kind of in the traditional ways you might think of using decision trees versus statistical models or more fancier statistical models. These graphical models are really a nice way of sort of providing explainable predictions to users that might be more important than the 2% improvement you get from a deep learning model. So in this work, I'll give you a live demo, assuming my internet connection is still good. So this is our system that's up. The URL is in the paper. You're welcome to play with it. So you can search on anything you want. We have some example ones you can just click on. And we go out to Google through the API, and we find various stories about that. So for each story, we can tell you the source of where we found it. You can see the headline here. We often highlight the keywords that our classifier is looking at. We're predicting for each source, or each story, I should say, whether it's supporting the claim or whether it's against the claim. We predict the reputation of each source. We compile all that evidence into an overall prediction. But then this whole thing is very interactive. So I know that deadspin.com is actually not a reliable source, so I'm going to just drag that reputation down, and I can see how the claim prediction changes. Or I know that, for instance, this article that predicted the article as being sort of for is actually against, so I can change that. So we have this sort of very interactive, playful space where users can combine their knowledge with what the system has. You can also look at, well, why does this particular source have this reputation? We generate a page for each source showing all the articles in the data set and how it did in terms of predicting claims correctly or not. You can explore any of these news articles, assuming it's actually still live on the web, to see kind of your own judgment about that. So anyway, that's a quick sense of the system. Oh, and you can toggle between crowd versus, system labels if you want to kind of look at that space as well. So let's see. Right. So the system architecture, again, we use the Google Search API. We have two logistic regression models for doing classification. This is essentially just prior work. So there's one for predicting the stance of the article. The average accuracy is above 70%, which already you could think is room for improvement, but it's also variable over claims, and we'll see more about that. Also a logistic regression model for predicting the veracity. So, using the reputations for sources to combine them to predict overall claim truth. So we use the emergent data set, which has been sort of a very popular one. And for testing, we just randomly pick 5 claims, numbered here 1 to 5, of which 3 of these are false and 2 are true. And to give you a sense about what the prediction models look like, so for instance, in doing stance prediction, we can see that the model's making quite a lot of errors on the first 2, doing much better later on. Similarly, in sort of predicting the overall truth of the claim, we're making a lot of mistakes early, better on the later ones. So yes, of course, one could always further work on the machine learning model and make it a little bit better, but these machine learning models will always be imperfect, and so I think the space is trying to think about how we have people reason and work effectively with imperfect machine learning models. So to evaluate, we ran a couple of user studies. So one is we have a control versus system. So the control group just sees all the set of sources and headlines, and they just have to predict whether or not they think a claim is true just based on that information. On the other hand, the system group gets to see the predicted reputations and the predicted stances for each of these articles. So we had a little over 100 participants through Mechanical Turk for this user study. They were asked to predict whether they thought the claim was true or not on this 5-point Likert scale from definitely false, neutral, probably true, definitely true. And we measured error in terms of their prediction versus this ground truth. So for instance, for a definitely false claim, if they said probably false, the error is 1. If they said definitely true, the error is 4. It's just a mapping onto this Likert scale. And so then, after they make this prediction, we show them the model's claim and kind of like Monty Hall, ask them if they want to change their answer. So in the control group, again, these people don't get to see the article stances or the source reputations, but then they see the predicted model, the model prediction for the claim veracity, whereas again in the system group, people see this, see the both stance, source, and then the final claim veracity prediction. So before anyone sees the claim prediction, if we look at the system group, those who have the access to the article, stance, and source reputation, compared to the control group, on claims 1 and 2, they have higher average prediction error. Claim 4, a little bit less error, and on claim 3 and 5, only small differences. In general, the trend we see is that human error roughly follows the model error, which is to say when the model's right, people learn from it and make better predictions, and when the model's wrong, they sometimes follow it down the rabbit hole and make wrong predictions themselves. Similarly, so this is just looking at stance prediction, or people's claim prediction after they see, for instance, stance. After the participants see the model's claim prediction, what do they do then? Well, we do see that the system group that has our access to stance and source reputation, they change their answers more than the control group. They have sort of smaller changes for errors, but we similarly see the same kind of trend, which is, again, human accuracy following the model for better and for worse. So we did a statistical significance test to look at these differences using a mixed effects model. So looking at sort of depending on whether they saw the number of correct stance predictions and the number of wrong stance predictions with the two-tailed test. And so basically with the correct stance predictions, it's slightly not significant, but our two-tailed test does include the unlikely prediction that seeing the correct stance predictions actually increases error. And similarly, another significance test after, details in the paper. The second user study, we had, again, 2 groups. So in this first study, there was no interaction. In this second case, the control group sees this stuff sees the interface but can't do anything with it, whereas the slider group can actually grab these sliders like I showed you in the demo and move them around. So to what extent does having an interactive interface rather than a static interface change things? Again, we had about 100 participants through Mechanical Turk. The same thing about predicting the veracity prediction. We also asked people to give their confidence in prediction. So if they were more confident with a right answer, they would get a higher score. If they were more confident about a wrong answer, they would get a lower score. And so generally, again, the group that used the slider had slightly higher score on average on these first 3 claims, again, where the model is doing worse. On claims 4 and 5, they sort of had lower first quartiles. The medians were about the same. We did again see that some participants were negatively impacted by the slider, which is in using it they actually did worse. But in general, on average, there was no statistical difference we saw between interaction versus non-interaction. So wrapping things up, I think there's a really interesting space in trying to think about fact-checking and information retrieval. The other hat I wear often is search engine design. So for instance, if we're trying to think about diversifying search results, is it better to bring in more diverse perspectives on an issue if it means I have to push down more authoritative and less relevant search results out of the search results page? You might think about, for instance, something like climate change. Should I show people that there's multiple perspectives on that, or should I just present them something more authoritative? How much should I be trusting my search engine? Or things like, does vaccination lead to autism? How do we help people with information evaluation and these kinds of things? So we had an intervention to try to provide more support for users, but we have to recognize there's also the potential for harm we cause here, right? There's potential added confusion. Now maybe people have to worry about not just looking at whether journalists are telling them the truth or not, but things about data bias or algorithmic bias. When you could customize source reputation on these things, you're allowed to create your own personal echo chamber. So basically, you can make the world look like you want it to look. And the great thing about that is you can definitely learn to trust the model because you can change anything you want so you know that it's doing reasonable things. But should we somehow not allow people to have that degree of flexibility? Or, if you let, as people change these reputations, if you sort of collect that at a global scale, you could imagine adversaries trying to game this. So in future work, some of the things we're thinking about is trying to make that kind of personalization more visible. So as you change source reputations, we show you something more about the echo chamber you're creating for yourself and kind of create a playful space for people to look at different kinds of biases and how that changes the worldviews. Or you could imagine sitting down with a friend who disagrees with you on an issue, and we can maybe, instead of just yelling at each other, look through the evidence available and say, oh yeah, you and I disagree about whether we trust this source, and if we change that, that would actually change our beliefs on the issue. So I think it's just sort of an interesting space for us to kind of play with these issues. And the author who can't be here is looking for a postdoc, if anyone has an opening or is maybe interested. He does both front end and back end, which is a nice combination of things. So just to wrap up, again, fact-checking I think is a lot more than black box prediction, which is by and large what it's been treated as right now in the natural language processing and information retrieval, and machine learning community. So I think things like interaction, exploration, and trust are really important. We propose this mixed initiative system, which has this combination, hopefully, of a back end to help with scalability and prediction, along with front end interaction. We want to support AI plus human collaboration, which I think is going to be increasingly important as AIs become more ubiquitous in our homes and workplaces. And I think we're touching on this issue of fair, accountable, and transparent AI, which is also one becoming increasingly important. So with that, I'll thank my sponsors and my co-authors who are circled here in red, and the talented crowd that helped us with this study. Thank you.
All right, well, I will begin before people start calling you out for fake news. It seems like, you pointed out the danger of creating echo chambers. I also, on another source of false confidence here would be the system's prediction essentially being presented as a fixed estimate. I wonder, given that you know that there's error in the system predictions, if you were to visualize that lack of confidence, do you think that it would have any impact on the conclusions that people drew? Would that be good, or would that actually cause them to essentially second-guess things that shouldn't be second-guessed?
Yeah, that's a really interesting question. We've played around with this a little bit, but don't have any good answers. So a couple things to think about. One is, the system has some uncertainty estimate over its prediction, and you could show that uncertainty. But as has been cutely talked about, there's the notion of the known knowns and the known unknowns, right? So the system thinks it's this degree of uncertain, and you can show that. But the system might be really confident and completely wrong. There was nice work by Panos Iporotis looking at helping people find the unknown unknowns for these systems. So one is, again, even this notion of error from the system is not necessarily reliable or not, and the people shouldn't even trust the system's estimate too much. I think we do want to highlight that this is a tool that is fallible, that can make mistakes, and might have some, utility. But also, I think it's important to some degree to undermine the tool so that people don't overly trust it. But I think we're still playing very much around what those interfaces might look like.
All right. Looks like they will take further questions offline. Thank you, Matt.
Thank you.